All right, so based off of where we left off in class, I decided I wanted to do dimensional analysis today. So we're going to go through a few things trying to figure this out. This is not something that's actually new to you. It's something you've done before. It's just something that you normally do in your head. Now, in chemistry, a lot of these types of problems are too complex to do in your head. So you're going to have to learn how to show your work in a situation like this, and that's where this whole process comes into play. So it's a systematic approach for solving both conversions and calculations, right? Showing all work in the process, right? You're going to use conversion factors. Conversion factors are ratios or fractions that come from definitions or equalities. So you'll have a situation like this. You guys know that 60 minutes is equal to an hour. So I can use that as a conversion factor. I can take that equality and turn it into a fraction. I can either say that there are 60 minutes in 1 hour in this fraction, or I can flip that and say that 1 hour is equal to 60 minutes in that fraction. And the reason why I would want to be able to do that is because maybe I want to know how many minutes are in 3 hours. And I know you can probably do that in your head, but we're keeping this simple to start off so that you can do it very easily and you can show your work in the process. So if I had 3 hours and I wanted to know how many minutes that was, I would need to multiply by that first conversion factor. I don't want hours left in my answer for the unit. So I want to divide by that 1 hour so I can cancel out that unit of hours, leaving the minutes on top. And based on this work, hours cancels, minutes is all that's going to be left on top. So I just take 3 times 60 and I get an answer. 180 minutes. All right. Or possibly I have a different problem. Maybe I'm told that it's been 540 minutes. How many hours is that? So again, I'm going to use a conversion factor. This time I'm going to divide by minutes instead of dividing by hours because I want hours in my answer. So I'll put the 60 minutes on the bottom so that minutes cancel out. According to my work now, I need to divide by 60. So I'm going to take 540 and I'm going to divide it by 60. And that should be equal to 9, I believe, hours. All right, so it's just a way to show your work when you're doing a conversion. A lot of these conversions you're used to doing in your head, but you have to be able to show work. So I know that you can probably do a lot of the problems that we're going to do today without showing work. But since that is a very important thing in the future, when we have complex problems and you really can't accomplish them without showing work, I'm going to need you to show work every single time. So the worksheet you do today, if you don't have work, you don't get credit for your answer. So you need to show your work correctly using conversion factors for everything. Yesterday we talked about metric conversions. So you'd have a problem like this, where you'd have maybe 12.45 centimeters, and I'd want to know what that would be equivalent to in meters. And this is really the same kind of thing. You could use dimensional analysis for this, but I taught you that you could also just move a decimal. So yesterday, you were looking at your tool, kilo, hectodeca, meter, liter, gram, decimilla, and you would just move the decimal appropriately to get your answer. So if centimeters is here, and I need to move 2 places to get to meters, that's what you would do to your number. You just move the decimal twice, so you'd know that it was 0.1245 centimeters. Or excuse me, meters. I just converted that. Units should change. But dimensional analysis in that situation, I'm going to need to multiply and divide. I'm going to need to know how many centimeters are in a meter to use a conversion factor to show work for this. Right? Usually, if it's a metric conversion, I'll just let you get away with moving the decimal. But again, I just want to show you in context here what you would be doing if you needed to show your work. If I had 12.45 centimeters and I wanted meters, I need to know how many centimeters are in a meter, and 1 meter is equal to 100 centimeters. So in my work, the reason why I move the decimal to the left 2 times is because in order to turn centimeters into meters, I'm going to have to take my 12.45 and I'm going to have to divide it by 100. And since I'm dividing by a power of 10, I can move the decimal. That's why that trick works to begin with. But to show your work appropriately using dimensional analysis, you have to set this fraction up the way I have so that centimeters cancel out. And you multiply and divide, right? You don't really need to multiply by 1, so you'll just take 12.45, divide it by 100, and you'll get the same answer we got before in meters, 0.1245. But this version shows the work a little bit better, and it tells you why you moved the decimal the way that you did. So again, sometimes if it's a simple metric conversion, I'll just have you do it, right? You can do it in your head and move the decimal back and forth. But if it's a more complex situation, you might have to show work, and that's why we're doing what we're doing today. Okay, so I have 4 different examples here that we're going to work through, just showing you how you would need to do this. They are complex, most of these, because I don't know one conversion that can go from one thing to the other in most cases. But if I wanted to know how many seconds were in 6 hours, I just need to work it out. So you always start with whatever you're given in the top right in your work. Excuse me, top left in your work. Right? In those railroad tracks, I think they used to call this in your other classes. So I have 6 hours up there. I don't want hours though, I want seconds. But I don't really know how many seconds are in an hour. I mean, you could figure it out, but I'm just going to start with what I do know and work my way towards seconds. So I may not know how many seconds are in an hour, but I know how many minutes are in an hour. There are 60 minutes in 1 hour, so I can use that as my first conversion factor. Now that I'm in minutes and those hours are canceled, I should be able to get to seconds now because I know there are 60 seconds in a minute. So my minutes cancel, and this is a little bit more complex because I have 2 conversion factors, but all I have to do is take that 6 and multiply it by 60 and multiply by 60 again. So I'm going to grab my calculator here real quick so I don't screw that up. 6 times 60 times 60 is equal to 21,600 seconds. So I want you to be able to show your work to get an answer, even if it's something that you could do in your head. I wouldn't have been able to do this in my head anyway, so I would need to show some work to get to the answer. So I would expect that you would as well. The next question. I have 3,840 ounces. I want to know how many gallons that is. I definitely can't do that in my head. So I'm going to have to work my way through it using this strategy, dimensional analysis, to get to my answer. Now, I already showed you in there that the easiest way to do this would probably be to change ounces into cups first and then cups into gallons. So again, start with what you're given, top left. I do know how many ounces are in a cup. There are 8 ounces in a cup. So ounces cancel here. I have cups instead of ounces. Now I should be able to get from cups to gallons because there are 16 cups in 1 gallon. And you may or may not know some of these conversions, and I'll usually give it to you if you need it. So, or you could look it up if you have to, but I do expect you to show work, right? Sometimes you have to look up that 16 cups in a gallon because that's not necessarily common knowledge anymore. So that's okay. If you need to ask, just ask. Quiz or test. But my cups cancel here. All I'm left with is gallons, so I'm going to multiply and divide. I don't have to deal with ones. I don't have to multiply by this 1 cup here. But 3,840 divided by 8, and then you divide it again by 16, you're going to get an answer of 30 gallons. Simple enough. Okay, next problem, 2 miles into yards. I don't know what that is off the top of my head, but I can work my way through it. So again, start from scratch. I got 2 miles. And I want yards. So I'll start with what I do know. There's 5,280 feet in a mile. So I can use that conversion to get out of miles and into something that I can relate to yards. And there are 3 feet in a yard. So now my work is complete. I've gone all the way from miles into yards, feet canceled, mile canceled. All I have to do is multiply and divide to get my answer. So 2 times 5,280, and then divide that answer by 3, and you're going to get 3,520 yards. So again, it's all just about a strategy here. This last problem was in the notes originally intended to just be a challenge, right? So I have a box that's got these dimensions. Its length is 3 feet, its width is 2 feet, and its height is 1 foot. And I wanted to know what the volume of that box was in cubic feet. So some of us may or may not remember an equation for volume for a box, right, to answer this question. But one thing I want you guys to get used to with this dimensional analysis, if you can start thinking in this way, you can solve problems without equations. You can just get an answer based off of the units themselves, right? All 3 of my measurements are in feet. And I want a cubic foot for an answer. So the only difference between this one and the first 3 that I did is that I don't want feet to cancel. I actually want to take 1 foot times another to get a cubic foot, because that's what a cubic foot means. So instead of having conversion factors, I just recognize that I have 3 feet times 2 feet. If you guys didn't notice, maybe having some issues here with thunder and lightning, so I can't quite finish this off the way I wanted to. The power just went out. But if I finish this off, 3 feet times 2 feet times 1 foot, and I'm doing this on my computer now instead of up on the whiteboard. Wow, that was a tough one there. But when I finish this off, 3 feet times 2 feet times 1 foot, I'm going to get an answer of 6 cubic feet. So again, even if you're not sure what the equation was right away, we're going to go through lots of problems that you can use this strategy to come up with an answer, but you don't always want those units to cancel, so you're not always dividing by a foot value to get rid of the other one. You needed, in this case, to collect those as you went. Multiply one times another. So that's how you get your answer. All right. So good thing we didn't have much left of these notes to go here, because this is kind of tough to do with no power. All right.